Chapter 8, Section 2 is titled Talking about Using the Distributive Property. And what we're going to do is kind of the opposite of what you think about when you're doing the distributive. A lot of times distributive means that you're multiplying. And with this whole chapter, we've been talking a lot about factoring. So we're going to talk about how factoring is like the opposite of what you did when you were using the distributive property. Now, previously, when we were talking about this chapter in Section 1, we went over a lot about the GCF, the greatest common factor. And some of that's going to kind of come back in this section here. When you're factoring a polynomial, what you're trying to find is an equivalent expression, so an equal expression that's using multiplication to kind of show how those quantities relate to each other. So you're talking about your factors, so like being able to write this out as the factorization. But now what we're going to do is start maybe setting things equal to 0, and those are going to be known as the solutions. Another way that you'll hear solutions talked about is they'll call them the x-intercepts. In a previous chapter, when we talked about x-intercepts, that was where the graph crossed the x-axis at. Those are going to be the roots or the solutions, the zeros. We've talked about some of those words before when we were looking for our answers here. With that greatest common factor that we talked about in the previous section, that's going to be what you're trying to find when you're factoring these things out, doing the opposite of the distributive property. What is the biggest number? What is the biggest amount of letters that you can take out from the terms so that you can be able to factor this easier? Now remember that our distributive property says that if I have something sitting out front of parentheses, basically what I can do is take that quantity and I can multiply it in. And we did a lot of this last chapter where we were drawing those arrows and we were multiplying that number out front times everything inside the parentheses to get a new quantity. What we're going to do today is the reverse of that. So if I look at different polynomials, I'm going to look at those individual terms and try to figure out what's the GCF. What's the biggest number that I could take out? What's the biggest number of letters I could take out? For this one, I have a 9, a 3, and a 6. I know that I can divide all of those by a 3. Because 9 can be divided by 3, 3 can be divided by 3, and so can 6. Then I also look at the letters. Now they all have A's, but the most that I could take out of all of them is just 1. Because this first, or the last term here, that 6A, only has 1 A. So you can see how they took this GCF of 3A, they pulled that out front, and then they wrote what was left on the inside. So what happens if you take those individual terms divided by 3a, and that's what we were doing last chapter when we were dividing these monomials. So when you're trying to factor using the greatest common factor, your GCF, you're going to want to find the greatest common factor of your coefficient. So what is the biggest number that you can take out of all of the numbers that you see in your problem? Then you try to find the GCF of your variables. Which one has the lowest exponent? So for example, if I had like x to the third, x to the fifth, and x squared, the smallest exponent I see is that x squared. So this would be the one that I would want to take out of everything. You don't want to try to pull out more than what you have. Your greatest common factor that you find goes outside of the parentheses, and then everything on the inside that's left is going to be divided. Okay? This is basically thinking of like doing undistribution, or you're undistributing everything, which isn't really a word, but we're going to make it a word here. And then everything being divided by means that we're doing the opposite of the distributive property. So let me show you how this works here. So for this first one, I look at all those numbers to begin with. So I've got a 10, a 5, and a 25. Okay? I try to think about what is a number that I could divide all of those terms by. Hopefully you can think of 5. They can all be divided by 5. Then I look at my letters. I've got x to the fifth, x to the third, and x squared. Remember that you only want to take the smallest one, so the one with the smallest exponent, which would be x squared. So my GCF is going to be 5x squared. So to write my answer, I put 5x squared out front of the parentheses, and what's left is if I take those three terms and I divide them each by a 5 and I take away x squared. So 10 divided by 5 would leave me with a 2, And if I have x to the 5th power and I take away 2 of those x's, I'm left with 3. So I write that as x to the 3rd. For the middle term, I would take negative 5 divided by 5, which is a negative 1. So you can write negative 1 if you need to. Or you can just look at the x's now. So you've got x to the 3rd that you started with, and you're taking out x squared, which would leave you with just an x. So I just write minus x and I'll put the 1 in front. And then for the last term, we're taking negative 25 divided by 5, which would be negative 5. And I'm taking out the x squared, so it's no longer going to be there. So I close my parentheses around that problem. So what I want you to do is look at these next couple of practice problems. There's 2 of them here that you can try. There's this one and this one right here. Pause your video, take a few minutes to do each one, and then come back to see if you did them right. So to get yourself started for this first one, you should have found your GCF. So the GCF for this one is 6x, because you can take a 6 out of everything, and the smallest exponent we see is just the x by itself. So we put 6x out front, and what you were left with then was a 2x to the 3rd minus 3x squared plus 4. For the next one, again, starting by finding your GCF for this one should have been a 3x. So 3x goes out front, and you were left with 10x squared plus 2x. And then this one, don't let this trick you. You took away the 3x, but that doesn't mean that it became a 0. It doesn't just disappear. Remember, anything divided by itself would leave you with a 1. So that's something that I see happen every once in a while. Students think that, oh, I took it out, so it's not there anymore, it's gone, and they don't write the plus 1. But remember, anytime that you're pulling something out completely, it's the same thing as dividing by itself, which is always going to equal 1. All right, so now that we've kind of talked about GCF and looking for it and finding it, now we're going to start factoring with something that has 4 terms to it. Okay, when you're working with polynomials that have 4 terms, and those terms don't all have a common GCF, what we can do is try to group our expression to see if there's anything that we could maybe take out of the groupings. Okay, so to do this, what you're going to want to do is basically cut your polynomial in half. You're going to group the first 2 terms together and group the last 2 terms together. Then you're going to look at each of those groupings individually, and you're going to pull out their GCFs. Once you've pulled out those GCFs, what's left inside of the parentheses should match. That's kind of a way for you to know that you're doing this right. Then after you've gotten it factored, you've pulled out your GCFs, you see that the pieces on the inside of the parentheses match each other, you should be able to write out your factored form by pulling the pieces that you pulled out, your GCFs, put those in a set of parentheses, and then pull the parentheses that match and write those down once again. If they want us to solve these for 0, then you're going to want to set them equal to 0 and solve for your letter. So you're going to see me do that as well, where I just take that a step further and I actually start finding my solutions. So for this first example here, I've got these 4 terms. And so we're going to kind of go through this step by step. So the first thing I do is I group my first 2 terms and my last 2 terms together. So it looks like this. I put parentheses around the 6x squared and the 3x. And then I put parentheses around the 2x and the 1. Then I pull out the GCF. So from the first grouping, I can take out a 3 from 6 and 3, and I can take out an x, because this first one has x squared and the second one has just x. If I take out 3x, what I'm left with is a 2x, so I'm just dividing those, and then again, remember we just talked about this, 3x divided by 3x is a 1. Now, out of the second grouping, I really can't take anything out because I can't take like a 2 out of 1. That wouldn't work out very nicely. And the 1 doesn't have an x, so I can't really take any letters out either. So instead, I'm just going to kind of bring it down as it is. So it says 2x plus 1. But what I would maybe suggest that you do is in front of the parentheses, put a 1. And you'll see why I tell you to do that in just a minute here. So now what you can see is the pieces inside the parentheses match. And remember I said that should happen. That kind of lets you know that you're doing it right. So what's left when I write out my factored form are the pieces that sit in the front, which are the 3x and that 1 that I told you to write down. Okay? So we're going to pull the 3x and the 1 and put that in its own set of parentheses. And then the other set just comes from what was repeated. So that 2x plus 1 and the 2x plus 1. And I just have to write it down one time. Okay, so this is our factored form for this problem. Now the last thing that they're asking us to do is to solve it. So they want us to set these equal to 0 and solve. So I'm going to take 3x plus 1 and set that equal to 0. And then 2x plus 1 and set that equal to 0. Now if you're at this point, this is stuff that we've been doing since chapter 2. We've been solving these types of equations. Both of these happen to be two-step equations, but this should be something that you should hopefully at this point be feeling pretty comfortable with. For this first one, I would subtract 1, and I would get 3x equals negative 1. Then I would divide by 3, and I would get x equals negative 1/3. There's one answer. And I'm going to do the same thing over here on the other side. I'm going to subtract the 1. So I get 2x equals negative 1. Then I divide by 2. And I get x equals negative 1/2. All right, let's take a look at this next example. This one's a little bit different because they threw in some minus signs here. So I want to go over this situation so that you know how to handle it. So the first thing I did is I changed this problem a little bit so that I've got addition happening here. So what I like to do is when I'm grouping, so I'm going to kind of do these two steps together. When I'm grouping, I'm going to grab the first two like normal because that has a plus sign there. But then I like to put a plus sign in the middle of my grouping, and then I put in the negative 10y minus 8. The reason why I do that is because when I start pulling out my GCF, what I'm probably going to need to pull out from the second grouping is a negative so that they become positive on the inside of the parentheses, and so that they'll end up matching what's left. Now I want to factor out my GCF, so I look at my first grouping. 5 and 4 aren't going to have anything in common, so I can't do anything with those numbers, but I can take out an x. And I'm left with 5y plus 4. Now from the second set, I'm going to take out a negative 2 so that I get positive 5y plus 4. So you can hopefully see here that the reason why I took out that negative 2 is so that the insides of my parentheses will now match. So then what I do for my next step is I again take out the pieces that are sitting out front, which is the x and the minus 2, and that goes in one set. And then I take the 5y plus 4 because those match, and I put that in the second set of parentheses. Now what they also want me to do is find the solutions, so I set these equal to 0. So I set x minus 2 equal to 0, I add 2 over on this one, and that gives me an answer of x equals 2. And then for the second one, it's going to be a little more complicated because we're setting 5y plus 4 equal to 0. So I subtract my 4. So I have 5y equals negative 4. Then I divide by 5, and I get y equals negative 4/5. So similar situation as far as like factoring goes and solving them, but just a little bit different in how we had to factor this one by pulling out that negative to make sure that the insides of those parentheses match. So like I said earlier, if you are doing these problems and the stuff inside of your parentheses don't match, you are doing something wrong. So you want to go back and look to see what did you take out, because whatever's left on the inside should be the same. Now, there are two practice problems here for you to do. So like similarly earlier in the video, I would want you to pause here, try to do these two practice problems, and then come back to see how I did them and what you should have gotten for answers. So for this first one, I start by grouping. In the first set, I was able to take out just a t. And that left me with 7w and a minus 5. Now, if you notice maybe right here that this already matches what's over here in the second set of parentheses, that kind of just tells you that you're not going to really be able to take anything out. But again, like I showed you earlier, maybe put that plus 1 just to make sure that you remember that you're going to have to pull that 1 with the t that's sitting out front. So the t and the plus 1, that goes in one set of parentheses. And then the 7w minus 5 goes in the other set. Now we're setting these equal to 0 to solve. So t plus 1, we set that equal to 0. 7w minus 5, we set that equal to 0. And hopefully at this point you're getting pretty comfortable with solving these types of equations, and you should have gotten t equals negative 1 and w equals 5 over 7. Now for the second practice problem, again we grouped the first two, and then I'm going to group the second two, and I'm going to put a plus sign in between them because I'm pulling that negative into the parentheses there. From the first grouping, I was able to take out an 8 and a g, and that leaves me with 2h plus 3. And from the second group, I want to take out a negative 1. That way this becomes 2h plus 3. And so now they match again. So then I have 8g minus 1, 2h plus 3. So there's my factors. Then I set them each equal to 0. And then again, when you solve, you should have gotten 1 over 8 for the first one, and negative 3 over 2 for the second one. For these last couple of examples, they're a little bit different in how they look from what we were just seeing because we have an equal sign separating the two terms that we're dealing with here. So to get started on an example like this one, you're going to want to get those terms on the same side of the equal sign. What I like to do is just try to keep that x squared term positive. So I'm going to move the 5x over to the other side, and I'm going to do that by subtracting it. So I'm going to write minus 5x on both sides here. And then what I'm going to have left is it's going to say now x squared minus 5x equals 0. So then what I'm going to do is look at those terms, x squared and the minus 5x, and I'm going to see what I can take out. So the GCF would just be an x. I can't really take any numbers out. I can just take out one x from both of those terms, and that would leave me with x minus 5, and that's equal to 0. Now what I'm going to do is set both of these pieces equal to that 0 to solve it. Now the first thing is to set this x equal to 0, which is just going to be one of your answers because that just says x equals 0. So there's one solution. And then for the other one, you're going to set that x minus 5 equal to 0. And then you're going to add 5 over, and that's going to leave you with x equals positive 5 for your other solution. So I want you to go ahead and take a minute here and try to do that same type of situation with this new practice problem. So what I did first is I subtracted the 3x from both sides. And so now it says 4x squared minus 3x equals 0. And then I factored out an x from both terms. So it says x times 4x minus 3 equals 0. And then we set the x equal to 0, and there's one of your answers, one of your solutions. And then for this other one, you should have set 4x minus 3 equal to 0. Then you needed to solve for x like we've been doing, and you should have gotten x equals 3/4.